Okay, no, we're doing transformations today and translations specifically, the first of the transformations. Okay, so we've got quite a few new words, keywords to go through first of all. They are as such. Transformation is a process that manipulates a two-dimensional shape. We probably know of manipulation in real life or non-maths life, but just in case, manipulate is to control or influence something. So could be moving it, could be changing it, you'll see. Object and image are two words I'm going to refer to a lot. So object, when you're told to do a transformation or reflect this, what you start with is the object, and then what you end up with is the image. And it's much easier if we can use those two words a lot so that you know what I'm referring to. So the object is what you start with, and the image, like as I said here, your reflection, you're the object, and when you look in a mirror, your reflection is the image, because it is you transformed. And then, so can you copy those down, please? Pause the video. And then we have these, a little brief description. So I would like you to copy this down briefly because I think this really helps. So the translation is the first one we're looking at today. And it's a slide. Basically, you're moving the shape. A reflection is a flip. You're kind of familiar with reflections, I'm sure. Rotation is a turn. And you'll notice that all these three, they stay the same size, meaning that their side lengths are the same and their angles are the same. And of course, therefore, they have the same area. So that's a real useful point to look for, especially if you're looking to see which transformation has occurred. If they're the same size, then it's one of these three, within reason. There is an enlargement which gives it the same size. So that's, and enlargement, change the size of the shape. It can actually get smaller. You're not always enlarging getting bigger, you're enlarging getting smaller as well. And if you look, because the arrows have gone from this one to this one, the pale one is the object and this is the image. Object, image, object, image, object, image. Okay, so please copy those down. Cool. So translation is just a way to move a shape around your page. I was going to go straight into that example. Yeah, we can do that. Right. So pause the video, copy that example, and then I'll show you. So the reason I've highlighted, this is a corner of the shape, which we call a vertex. Plural, so many corners is vertices. So this vertex is because for all your transformations, you want to be transforming a vertex, not the whole shape. Don't try and imagine, oh, I'm moving the whole shape. It's much easier, much easier, much less likely to make a mistake if you use a corner at a time, which is exactly what I've done here. So I'm going to use bottom right. I think I always tend to use bottom right or bottom left, but it doesn't matter as long as you remember which one you've used. So perhaps highlight it like I have. So translate the object 3 squares right and 2 squares down. Can I change that? I know I should write it down. I beg your pardon. It's not ideal if it goes off the axis, is it? Sorry, translate the object 3 squares right and 2 squares up. So what we do is we start at the corner and we are counting squares. So we have not gone 1 square right. This way is right. We have not gone 1 square until we get to here. Don't go counting middle of the squares as some students do. We go 1, 2, 3 squares right, 3. So a nice thing you might find helps. You'll have to accept my apologies if mine's a little bit scrappy. But just draw yourselves a root because then it's so much easier to check your answer. It doesn't say in the question, don't draw your root. So translate the object 3 squares right and 2 squares up. Nice. And then I can put a nice, some kind of, whoa, that's a little bit astray. I can put X marks the spot, and I know, look, that this is this corner because I've made it nice and obvious. I started bottom right. I've shown my path, 3 right, 2 up, and I've labeled it. So you don't have to necessarily, particularly with translations, translate the other corners, because the orientation, meaning which way up it is, stays the same, the size stays the same, and it's not been reflected or anything. So you can probably see that the shape goes something like comme ça. It will often say label the image, oops, A apostrophe. It may say B or C or something, but if it doesn't ask for that, we would label this A apostrophe, which means basically the image of A. So all we've done is moved it 3 to the right and 2 up, and the key bit is to translate a corner. Now we can do some more, but what we need to do, we have a different way, some notation for this. Rather than describing 3 left, 2 up, 5 down, whatever, we use a vector. Not to confuse matters, but I am going to use a spot of algebra. A is a number, B is a number. It's a little bit like a fraction, that's awful. But there is no line in the middle. And there are brackets either side. So this one, the number on top, if you relate it to your coordinates, you can perhaps guess what that would be, because one's going to be left, right, one's going to be up, down. The A is left, right. And positive is right. Positive equals right. Now, oh dear, look at my nice spelling there. There's a couple of bits there. For one, is it not logical, given that we are often using coordinate axes, if it's not logical that if the first number describes left and right, that if it's positive, it goes up the x-axis? I just pointed you, you can see. It goes up the x-axis, just logical. And then if it's negative, it goes left, down the x-axis. Positive. Good. And secondly, I think if you think, you've got to be careful comparing it to coordinates, because it's not coordinates, it's a vector, it's describing movement, it's quite different. But on the flip side, I would think if you rearrange these numbers, because we know along the corridor upstairs, x, y, if I rearrange the one over the other, I'd probably put the B underneath. So I think it's quite logically done. I.e., if you forget in an exam, you guess the logical way, and I think you'll be right. Now B is, of course, up and down. Guess which way is positive. Think about the y-axis. Positive, maybe spelled correctly this time, treat myself, equals up. Cool. So copy that down, please, obviously. And then can you think this description here, 3 squares right and 2 squares up, how would you write that? So we know that it's going to be a awful bracket, Mr. Scudamore. And it's going to be one number above the other. The top number tells us left and right. So we've got 3 squares right. Okay, 3, is it positive or negative? Well, it's going right, so it's positive. Then 2 squares up, it's going to be a 2. Is it positive or negative? Well, it goes up, so it's positive. So that, look how much easier it is. Translate 3, 2, or translate the here. So that's why we use vectors. Okay, I'll do a couple more examples, and then I'll just get you to practice the vectors before we move on to further translating. But you can see it's pretty straightforward. Up. That was left and right. Left, 4, right. Been a long week, eh? Down 3. A, B, C. These are examples, but I'd like you to have a go. Right, 1, up, 3. Didn't really mean to set it out rather one on top of the other, rather like a vector. Whoops. And then this one, shall we do left, 2, down, 9. So pause the video, have a go at those, please. So this one, the top number is lefty righty, so it's going to be 4, and it's left, so it's negative. The bottom number is uppy downy, it's 3, and it's down, so it's negative. Comme ça. Very good at using the brackets on this jazzy little number. Okay, top number, A, is left and right, it's 1 and it's going right, so it's positive. And then up 3 goes on the bottom, and that is also positive. Then we've got the top number is 2 and it's going left, so it's negative. It goes down the x-axis, and then this one is going down the y-axis, so it's 9, but it's negative. Okay. There, please. Them and them. Right. Can you write those vectors out in words, please? And can you convert the other way around, from words into vectors, like I've just been doing? So perhaps, because we didn't do an example like this, perhaps just we'll do one. So the top number tells us the lefty righty, so it's going 1 and it's left or right. Which way? It's going up the x-axis, so it's 1 right and this is 1 up. The bottom number is up and down, and because it's positive it goes up. So this is 1 right, 1 up. That'll do fine, you don't need any more words than that. So pause the video and answer those questions, please. Great. The answers to those questions, I think the answers in 2 separate bits. They are the first section, question 1 of exercise 1, those are the answers, and then question 1 of exercise 2, those are the answers. So mark your answers, please. Okay.